Very, very good questions, sir. Very, very good questions. How many set of two different numbers are there whose LCM is 72? How many different set of two numbers are there whose LCM it is 72? Listen carefully. Again this question. First we will solve the traditional method. Then I will tell you Anil Nair's way of solving the question. Traditional method. Then we will see Anil Nair's method. Anil Nair's method will help you to solve the question in seconds. Traditional method will help you to understand the concept better. Respect the traditional method, but optimize the number of steps during using my way of solving. Now, how many set of two different numbers are there whose LCM is 72? First point, variables are not present in the question. Variables are not present in the question. If variables are not present in the question, then it is an unordered pair. We are determining unordered pair. That means A comma B is equivalent to B comma A. A comma B is equivalent to B comma A. Reverse case should not be taken. That is first understanding. Another one, how many set of two different numbers are there? We should not take the case LCM of 72 comma 72 equivalent to 72. How many set of two different numbers are there? 72 comma 72. Any number with the same number, the LCM will remain the same. LCM of 4 comma 4 is 4. LCM of 6 comma 6 is 6. LCM of 8 comma 8 is 8. Question is two different numbers. Reverse case should not be taken and same number should not be taken. Otherwise you will get more cases, duplication of cases, you will get it. So first I will do for an ordered pair, then I will eliminate the cases. Ordered pair means three cases I will take. A comma B is not equivalent to B comma A. Total cases I will take, then I will remove the cases. I will get unordered pair. Listen carefully, sir. It's a very interesting problem. Generally in all your textbooks, numbers will be given, LCM we have to find out. But LCM is given, we have to find out the number. How am I doing it step by step? Listen carefully, sir. Step number 1. So in ordered pair, first I will do. Let the two numbers be A. LCM of A comma B is equivalent to 72. We do not know anything about A, we do not know anything about B. But what we know is the LCM of A comma B is 72. We don't know anything about A. We don't know anything about B. But the LCM of A comma B is 72. 72 can be written as highest power of prime bases 2 power 3 into 3 square. Answer contains which all prime bases? Answer contains 2 prime bases 2 and 3. Answer contains 2 prime bases 2 and 3. So the question should have 2 and 3. So 2 power x1 into 3 power y1. 2 power x2 into 3 power y2. 2 power x1 into 3 power y1, 2 power x2 into 3 power y2. What is the definition of LCM? LCM is defined as the highest power of the given prime bases. LCM is defined as the highest power of the given prime bases. This is the definition of LCM. We will use the definition of LCM to calculate this answer. Listen carefully, sir. A we don't know, B we don't know, but 72 it is 2 power 3 into 3 square. What is the 3? 3 it is defined as the highest power of the given prime bases. So maximum of x1, x2 it is 3. Am I right? x1 can take 3, x2 can take 0, 1, 2, 3. x2 can take 3, x1 can take 0, 1, 2, 3. LCM always takes the highest power of the 3 prime bases. Either x1 should be 3 or x2 should be 3 or x1 and x2 both can be 3. So maximum of x1 and x2 has to be 3. If x1 is 3, x2 will be 0, 1, 2, 3. Think logically, sir. 2 power 3, 2 power 0. What is highest? 2 power 3. 3, 0, 3, 1, 3, 2, 3, 3. We'll write down the cases here. x1 can take 3, x2 can take 3, 1, 3, 0, 3, 2, 3, 3. If x2 takes 3, x1 can take 0, 1, 2, 3. Either x1 can take 3 or x2 can take 3 or both of them can take 3. Next case is 0, 3, 1, 3. Next is 2, 3. Next is 3, 3. 3, 3, 2 times I wrote. 1, 2, 3, 4, 5, 6, 7. Total 7 cases are there where x1 can take 3. See here logically. Answer contains 2 power 3. This 2 power 3 should be the highest power of the given prime base. Either x1 can take 3, x2 can take 0, 1, 2, 3 or x2 can take 3, x1 can take 0, 1, 2. 3, 3 it is duplicated. Similarly, LCM always takes the highest power of the given prime bases. Maximum of y1, y2 it is 2. Maximum of y1, y2 it is 2. If y1 takes 2, y2 can take 0, 1, 2. What are the cases? 2, 0, 2, 1, 2, 2. 2, 0, 2, 1, 2, 2. Or if y2 takes 2, y1 can take 0, 1, 2. 0, 2, 1, 2 and 2, 2. 2, 2, 2 times I wrote. 2, 2 times I wrote. 1, 2, 3, 4, 5. Total how many cases I got here? Maximum of y1, y2, 5 cases. Maximum of x1, x2, how many cases I got? 7 cases. With every case of 3, 0, 5 cases of y1 and y2 are possible. If x1 take 3, x2 takes 0, y1, y2, 2, 0, 2, 1, 2, 2, 2, 3, 0, 2, 1, 2. For one value, there are 5 subcases. So 7 into 5, 35 cases. How many values A, B can take such that LCM of A, B is 72? Answer is 35. But in this 35, it is an ordered pair. 17 cases will be A into B. 17 cases will be B into A. One case will be A equivalent to B. This case should not take, this case should not take. So answer for this question is 18. Answer for this question is 18. Why? Because if variables are not present in the question, it is an unordered pair. Unordered pair, reverse case, it is not possible. Question is different numbers from 18, one more case needs to be eliminated. LCM of 17, 17. What is the answer? 17 cases. I hope the idea it is clear. Entire idea is based upon this point. LCM is defined as the highest power of the given prime bases. LCM it is defined as the highest power of given prime bases. Why it is maximum of x1, x2 it is 3? Because answer contains 72 which is 8 into 9. Either x1 contains 3 or x2 contains 3 or x1 and x2 contains 3. If x1 contains 3, x2 can contain 0, 1, 2, 3. If x2 contains 3, x1 can contain 0, 1, 2, 3, 3 already 2 times. 1, 2, 3, 4, 5, 6, 7. 7 cases, and here it is 3 2s. Similarly, if x1, y1, y2 it is 2. If y1 takes 2, 2, 0, 2, 1, 2, 2. 0, 2, 1, 2, 5 cases. For every one case, there are 5 subcases. 7 into 5, 35. 17 cases, A into B. 17 cases, B into A. Eliminated. One case, A equivalent to B. Question is two different numbers. Question is two different numbers. So one case is eliminated. Suppose this is the process to solve. If there are 2 variables, if there are 3 variables, again we have to do 2 power x1 into 3 power y1 into some other power z1. Like that, a lot of cases we need to solve. Cases we will not do. Now Anil Nair's approach. Now see here. LCM of A, B equivalent to 72. 72 equivalent to 2 power 3 into 3 square. 2 power 3 into 3 square. Now, what are the cases we got? See here. First we will write down the cases. Then it will be crystal clear. It is a one-step answer, sir. 30, 31, 32, 33, 0, 3, 1, 3, 2, 3 and 3 comma 3. That means to distribute these power of 2, to distribute this power of 2, totally how many cases I got? 1, 2, 3, 4, 5, 6, 7. 7 cases I got. Can I say at least one? At least one means in the doublet, if you see, at least one of them contains 3. 3, 0, it contains 3. 3, 1, it contains 3. 3, 2, it contains 3. 0, 3, it contains 3. It contains 3. It contains 3. At least one. At least one, it is nothing but total minus none. Listen carefully, sir. If you understand this negation approach, answer will be in single step. At least one is nothing but total minus none. Suppose if I take whole numbers, it is defined as 0, 1, 2, 3, 4, 5. These are total numbers. Minus none. None is 0. I will get at least one. Yes or no? At least one is nothing but total minus 1. 9. If you understand this simple concept, you got the answer. At least one is defined as total minus none. What is total? Total. Arrange all the powers of 2 onto A. What are all the total powers of 2 that can be arranged? 2 power 0, 2 power 1, 2 power 2, 2 power 3. Similarly, B also can take 2 power 0, 2 power 1, 2 power 2, 2 power 3. 4 into 4, 4 square cases. It is total minus, listen carefully, sir, minus none. None means don't take 2 power 3. If I don't take 2 power 3, 2 power 0, 2 power 1, 2 power 2. Similarly, B can take 2 power 0, 2 power 1, 2 power 2. So, how many cases? 4 square minus 3 square. 4 square minus 3 square. 16 minus 9, which is 7. Listen carefully, sir. You might get a doubt here, so I will explain in clearly. At least one. This slide should help you to understand what are that cases. At least one is total minus none. If you understand it, 4 variables, 5 variables, it is very easy. At least one is total minus none. Listen carefully, sir. What I did, LCM of A comma B, it is 72. 72 can be written as 2 power 3 into 3 square. Listen carefully. First, total cases. What are the total cases? 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 0, 2 power 1, 2 power 2, 2 power 3. Let me write down the cases. 0, 0, 0, 1, 0, 2. Only powers of 2 I am writing, sir. 0, 2. Next is 0, 3. 1, 0, 1, 1, 1, 2, 1, 3. Next will be 2, 0, 2, 1, 2, 2, 2, 3. Next will be 3, 0, 3, 1, 3, 2, 3, 3. These are the total 16 cases. Minus none. What do you mean by none? None means don't take the power of 2 which is required. Take all the other powers. 2 power 0, 2 power 1, 2 power 2. A can take 3 cases. Similarly, B can take 2 power 0, 2 power 1, 2 power 2. Minus, what are all the cases? 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. See here, beautifully you will understand which all cases are eliminated. If you see 0, 0, 0, 0, this case out. 0, 1, 0, 1 out. 0, 2, 0, 2 out. 1, 0, 1, 0 out. 1, 1, 1, 1 out. 1, comma 2, 1, comma 2 out. 2, 0, 2, 0 out. 2, 1, 2, 1 out. 2, 2, 2, 2 out. What is the remaining there? Remaining cases are 0, 3, 1, 3, 2, 3, 3, comma 3. Next cases 3, 0, 3, 1, 3, 2. Isn't it? These are the cases we got in traditional method 1. Either x1 can take 3 or x2 can take 3 or x1 and x2 both can take 3. At least one can be defined as total minus none. What is total? First take the power of 2. Arrange all the powers of 2 for A. 2 power 0, 2 power 1, 2 power 2, 2 power 3. How many cases? 4 cases. Similarly, B also can take 2 power 0 to 0, 2 power 3. So, which is 4 square minus next 3 power 2. Next is arrange all the powers of 2 excluding the given one. 0 to 2, 3 cases, 0 to 2, 3 cases. 4 square minus 3 square, 7. I hope it is clear. At least one is nothing but total minus none. Think logically. Whole numbers is 0, 1, 2, 3, 4 and so on. At least one. We require 1, 2, 3, 4, 5 and so on. That is nothing but total whole number set minus none 0. From whole numbers, if I subtract 0, am I getting natural number? Yes. From the total set, if I am subtracting none, I will get at least 1. Are you all with me? At least 1. Or you look at it like this. In a class of 100 students, 20 students do not like maths, 80 students like greater than or equivalent to one subject or do not like any subject we will take. In a class of 100 students, 20 students do not like a subject, 80 students like minimum one subject. So, from total, if I subtract the total number of students who do not like a subject, from total, if I subtract the number of students who do not like a subject, I will get a students who like minimum one subject. Yes or no? 100 minus 20, it is 80. From total, if I subtract the number of students who do not like a subject, I want at least one. At least one of them contains 3. Similarly, 3 power 2. Tell me the answer for 3 power 2. Total minus none. Total will be A will take 0 to 2 or B will take 0 to 2. Minus none. None means B will not take 3 power 2. 3 power 0, 3 power 1. 3 square minus 2 square. 9 minus 4, 5. Answer is 7 5s are 35. A simple understanding of total minus none. You will get the answer very easily. There are no cases. I will do at least 5 to 6 questions. Most complex CAT question, it will take less than 10 seconds for you to solve. Total minus none. Total cases, these are the 16 cases, minus not having 3, 3 square 9. If I subtract, I got every case which contains 3. Highest LCM is defined as the highest power of the given prime basis. LCM is defined as the highest power of given prime basis. I hope the idea it is clear. Total powers of 3. 3 power 0, 3 power 1, 3 power 2. 3 power 0, 3 power 1, 3 power 2. Minus, don't take 3 power 2. In case if you have not understood it clearly, another 5 problems it should be clear to you. 7 into 5, 35. 17 A into B, 17 B into A equivalent to B. A equivalent to B. So these both can be eliminated. Answer is 17. I hope it is clear. Total minus none. Next slide, listen very carefully, sir. Next slide, listen very carefully. You will get the answer. How many pairs of numbers have their LCM as 100? Listen carefully. How am I solving this question? It takes hardly less than 20 seconds to solve. LCM of A comma B, it is 100. First we will do for ordered pair. Next step will be, we do not know what is A. We do not know what is B. But the LCM of A comma B is 100, which is 2 square into 5 square. So this will be 2 power x1 into 5 power y1, 2 power x2 into 5 power y2. Into 5 power y2. Just for our understanding, second question, I am writing maximum of x1 and x2 should be 2. LCM always takes the highest power of the given prime basis. Maximum of y1, y2 should be 2. That means either x1 can take 2 or x2 can take 2 or both of them can take 2. That means at least one of x1 comma x2 takes 2. Are you all with me? Takes 2. Similarly, y1 comma y2 takes 2. At least one out of them. At least one means both of them can also take 2. Now we will use Anil Nair's way to solve this question. Anil Nair's way, very easy way, negation way. Instead of doing the cases, we will do at least one. At least one. At least one is defined as total minus none. Total minus none. Total cases. Tell me total cases. How much it will be? Question is LCM of a comma b equivalent to 2 square into 5 square. 2 square into 5 square. A can take how many cases? 2 power 0, 2 power 1, 2 power 2. 3 cases. B can also take 3 cases. None. Don't take 2 power 2. What are the remaining cases? 2 power 0, 2 power 1. 2 cases. B also 2 cases. Since the powers are same, the same expression will be repeated. 9 minus 4, 5. 9 minus 4, 5. 12 cases. 12, 12, 1. A greater than B, A equivalent to B, A less than B. Reverse we need to eliminate. How many values A comma B can take such that LCM of two numbers, it is 100. Very, very good question, sir. A beautiful question for us to compute the input values when the output it is given. Very unique question, sir. At least one is given by total minus none. Again, last time I am explaining why these 3 came. Because A can take all the powers of 2 or B can take all the powers of 2. Minus none. None means A cannot take 2 square. 2 power 0, 2 power 1. B can take 2 power 0, 2 power 1. 3 square minus 2 square. 3 square minus 2 square. Now 1 minute, sir. I will draw some very beautiful conclusions. These is nothing but 3 square minus 2 square into 3 square minus 2 square. Why these 3 square? Why these 3 came? It is nothing but 0 to 2. Am I right? 0 to 2. Why these 2 came? How many variables are there? Total 2 variables are there. Either A can take or B can take. Just remember this, then I will solve in the next slide multiple problems. I hope this logic is clear. No need to take maximum of x1, x2 equivalent to 2, maximum of y1, y2 equivalent to 2. Now see here. Now, a lot of questions I will take it up. Question. LCM of a comma b comma c equivalent to 120. How many values ABC can take? How many values ABC can take? Next question. LCM of ABCD equivalent to 16. How many values ABCD can take? Next question. LCM of AB equivalent to 2 power 6 into 3 power 4 into 5 square. How many values AB will take? Seems like a very tough question, but actually these are all very, very easy questions. LCM of ABC, it is 120. How many values ABC can take? LCM of ABCD, it is 16. How many values ABCD can take? A comma B. What is the concept that we used here? At least one. We will write down here. At least one. At least one is defined as total minus none. At least one. It can be written as total minus none. First, step number 1. Condense this 120. 120 is 2 cube into 3 into 5. 8 3s are 24. 24 5s are 120. 16 it is 2 power 4. At least one is total. Total means 2 power 3. From 0 to 3, how many cases are there? 4 cases. A can take 4 cases. B can take 4 cases. C can take 4 cases. In 64 ways, you can give the powers of 2 onto A, B and C. 0 to 3, 0 to 3, 0 to 3. Minus. Don't give 2 power 3. Remaining give all the cases. 0 to 2. How many cases? 3 cases. A can take, B can take, C can take. 4 cube minus 3 cube. Similarly, total minus none. Give the powers of 3 onto A. 3 power 0, 3 power 1. How many cases? 2 cases. A can take, B can take, C can take. I hope you are all there with me. None. Don't take 3 power 1. So 3 power 0. 1 case. A can take, B can take, C can take. Powers are same, so it will be duplicated. 2 cube minus 1 cube. Answer over. Simple step. 64 minus 27, which is 37. 8 cube minus 1. 8 minus 1, 7 into 7. So this is 37 into 49. Whatever the answer that you get, that will be the answer, which is nothing but 1850 minus 37, which is 1813. For 49, I wrote it as 50 minus 1. 37 into 50 is 1850 minus 37, answer is 1813. At least 1 it is defined as total minus none. Simple question. 2 power 4, total 0 to 4, 5 cases. A can take, B can take, C can take, D can take. 0 to 4, 0 to 4, 0 to 4, 0 to 4. Minus none. Don't give 2 power 4. 0 to 3, 4. A 5 power 4 minus 4 power 4. 625 minus 4 power 4 is 256. So these, how much it is? These 16, 9, 11, 6. 4, 16, 9. Am I right? 9, 15, 61. 469 cases are there. 469 cases are there. Where LCM of A, B, C, D, it is 16. 1, 1, 1, 1, 1, 16. That only can be distributed in 4 ways. 1, 2, 1, 2, 1, 2. See here. 1, 1, 1, 1, 16. These 4 factorial by 3 factorial. 1, 2, 4, 16. LCM it is 16. 4 factorial 24. 1, 2, 2, 16. 4 factorial by 2 factorial. Like that totally 469 cases are there. 469 cases are there. LCM of A comma B. Now tell the answer, drop the pen. Now this should be very easy for you. Total 0 to 6 minus 6 square. Total minus none. 3 to 4, 0 to 4, 5 square minus 4 square. 0 to 2, 3 square minus 2 square. Single step. 5 seconds. Initially it will take 20 seconds. But once you understand Anil Nair's way of solving, you can do it in fingertips, sir. 49 minus 36, 13. 25 minus 16, 9. 9 minus 4, 5. 13 5s are 65 into 9, which is 585. 585. In case if you want an unordered pair, 585. Half of the cases will be A greater than B. Half of the cases will be A less than B. One case will be A equivalent to B. I hope these 3 questions are very, very clear to you. Even if the question is any number of variables, let him give. The answer should be there in fingertips. Suppose if it is 20. Tell me the answer. LCM of 5 variables, it is 20. 2 square, 0 to 2, 3 cases. 3 power 5 minus 2 power 5. Finish. 2, 5 power 1, 0 to 1, 2 cases. 2 power 5 minus 1 power 5. Answer over. 3 power 5 minus 2 power 5 into 2 power 5 minus 1 power 5. This model clear? First, if you see, that is the beauty of thematic based learning. First we understood the definition of LCM, then we did the LCM for the given numbers. If answer options are there, how to compute it, then LCM is given, one number is given, another number, missing number we found out, then only output is given. What can be the input so that this output will come? That is the beauty. Everything is very structured, sir. I hope the idea it is clear.